Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on the midpoint theorem trio of theorems. And this video, we're going to focus on the first one, which says Theorem 1, perpendicular line from circle center bisects chord. And this is for mathematics grade 11 Euclidean geometry. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 and part 3 of this trial series of videos on the midpoint theorem, and more videos on theorems we upload in the future. We have a lot to cover, so let's start. In summary, we're going to look at number 1, the midpoint theorem trial. I'm going to show you exactly what I mean by the trial. It's a group of 3 theorems, and you're going to see exactly what it is that I'm talking about. Number 2, we're going to look at the 3 steps on how to prove a theorem. A simple 3-step that I developed to make it easier for learners to understand the process of proving a theorem. And number 3, we're going to look at a deep dive of step number 1, which is understand the theorem. Number 4, we're going to look at a deep dive on step number 2, which is what is the goal? What are you required to prove and how do you figure it out? Number 5, we're going to look at step number 3, which is how to pick a strategy. You pick a strategy, but how do you do it? Number 6, and lastly, we're going to look at how to apply Theorem 1 in questions where you are expected to calculate or when you are proving another theorem. We have a lot to cover, so let's start. First of all, let me take you through the trial. All right, in this trial, we've got number 1. Theorem number 1 is the theorem that we're going to focus on in this video in particular. It goes the perpendicular line from circle center bisects chord. That is number 1. And this is the picture that it looks like. So you have this line OP with a corner angle, meaning right angle. So it must be drawn perpendicular to the chord AB. That's what we start with. And you are required to prove that AP equals to PB. In other words, OP bisects the chord. I'm going to explain what the words mean in detail as we go through this theorem. Number 2 in the series of the trial is the converse. A converse is a reverse of a theorem. Now, if you want me to do another video explaining what exactly these words mean and how you can generalize it in theorems in general, I can do that so you understand how theorems are proven. Now, this says the line from circle center to midpoint of a chord is perpendicular. In the first one, you started with OP perpendicular to AB. Now they are telling, and then you were supposed to prove that it bisects the chord. In other words, AP equals to PB. No. In this one, you start with it bisecting the chord. In other words, you start with AP equals to PB, and you're supposed to prove that, therefore, it is perpendicular. What does perpendicular mean? I'm going to explain in detail as we deep dive, but basically it means that they meet at right angle, meaning that you are required to prove that this angle OPB or OPA for that matter is equals to 90 degrees. That's what number 2 is about. Number 3 is what we call a corollary. In other words, it's a combination of the first 2. So it's the theorem and its reverse, the converse, put together. And this is what they're saying. They're saying the perpendicular bisector of chord passes through center circle. In the first one, you had the perpendicular OP perpendicular to the chord, right? In the second one, the converse, you had it bisecting the chord. In other words, you started with AP equals to PB. In this one, you start with both the perpendicular part and the bisection part. So they're saying if this is the case, the line that is perpendicular to the chord and bisects the chord has to go through the center circle. That's what the third one in the trial is about. We're going to do a deep dive on this in another video, video number 3. Please subscribe for that. But for now, let's go back to this one that we want to prove. Now, let's look at the 3 steps on how to prove a theorem. Now that we know what the trial looks like, and you can spot it, and you can spot the difference between the trials, now let's look at the process on how to prove a theorem. Now, if you break it down into 3 simple steps, this is basically what it is all about. Number 1, know your theorem. What do I mean by knowing your theorem? Understand what the theorem is about. Know what the words mean. What is the theorem about? If you don't understand what the theorem is about, you end up being forced to cram or memorize, and that's not meaning you understand anything. Now, let's look at how you do that. You look at the statement of the theorem. For example, in this one, the first one in the trial, it says if a line is drawn from the center of a circle perpendicular to a chord, then it bisects the chord. Whatever word you don't understand, annotate it. Find the meaning. Write it down so you understand what it means. What does it mean to be perpendicular? It means to meet at right angles. What does it mean to bisect? To bisect is to cut into two equal parts. That's what I mean by understanding the theorem. Understand the theorem. If a line is drawn from the center of the circle, blah, 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 we're going to do this when we look at the theorem in detail. But that's what understanding the theorem is. Another thing that is going to be very helpful to you is to number 2. Know what the goal is. What is the goal? What are you required to prove? If you don't know what you're required to prove, then how are you going to do that? How are you going to prove it? Now, in this case, you are required to prove that AP is equals to PB. And I'm going to explain exactly how we arrive at that conclusion and why we end up doing that from the words and you understanding the words. Number 3, the strategy. Pick a strategy. What strategy are you going to use? For this first one in particular, you've got 2 options. The first one is to use congruency. Number 2 is to use the theorem of Pythagoras in order to prove that. We're going to do a deep dive just in a second. So bear with me. I'm going to show you exactly what it is that I mean. So in summary, these are the 3 steps on how to prove a theorem. Number 1, know the theorem. Number 2, what is the goal? What are you required to prove? And number 3, what strategy are you going to use to get to the goal, which is what you are required to prove? That's a simple 3-step process on how to prove a theorem. Now let's look at theorem number 1. The reason for this video, let's do a deep dive. Let's take those steps and use them to prove this theorem so you can see exactly how to apply each step, every step of the way. Now here is the name of the theorem. It says perpendicular line from center circle center bisects chord. Now here is the statement. The statement says if a line is drawn from the center of a circle perpendicular to a chord, this is a word that you might need to explain further, so let's underline it. Perpendicular, I'm going to explain what it means now. If a line is drawn from the center of a circle perpendicular to a chord, okay, perpendicular to a chord, then it bisects the chord. Here's another word that you might need to understand in detail. What is to be perpendicular? When something is perpendicular, or when a line is perpendicular to another line, it means that it meets it at right angles. To meet at right angles, at 90-degree angles. That's what perpendicular means. To a chord, then it bisects the chord. To bisect is to cut into 2 equal halves. Cut into 2 equal parts. That's what bisect means. To cut in half. That's what it means. They say if a line is drawn from the center of a circle perpendicular to a chord, then it bisects the chord. Now let's use this diagram that you will be given. What is it that they're talking about? If a line is drawn from the center of the circle, that line is OP. If this line OP is drawn from the center of the circle perpendicular to the chord, AB is the chord, then it bisects the chord, meaning that if this line OP is drawn perpendicular to AB, then it will cut AB into 2 equal parts, meaning that AP will be equal to PB. And that is what you are required to prove. Right, so that's step number 1, the theorem. We've understood the theorem. We've understood the theorem. We've annotated the theorem. And here it is that we have. So there is the theorem. We've understood it. Now, let's look at what are we required to prove. From the theorem, this is what we are required to prove. If OP bisects AB, then it cuts it into 2 equal halves, meaning that therefore AP will be equal to PB, meaning that P, the point P is the point halfway of the line AB, or the chord AB if you want, meaning that AP is equals to PB. I hope now you understand. So that's what we are required to prove. We are required to prove that AP is equal to PB. Now step number 3, so that was step number 1, the theorem. We're done with that. Step number 2, what is the goal? The goal is we are required to prove AP is equals to PB. We are required to prove that AP equals to PB. Number 3, strategy. Number 3, strategy. What is the strategy that we can use? For this one, there are 2 strategies. I'm going to start with the first one. Strategy number 1, which is the one I personally prefer, but if you prefer the other one, I'm going to do both of them. So strategy 1, let's look at option 1 of this strategy. Option 1 is congruency. Now, when it comes to congruency, remember there are 4 ways you can prove that 2 triangles are congruent. Remember proofs of congruency? Proof of congruency. All right, we've got side, side, side. We've got side, angle, side. And then we've got angle, angle, side. And the last one that usually is what we use when we are dealing with right-angled triangles is right angle hypotenuse side, RHS. These are the 4 ways of proving congruency. Proof of congruency. Reasons for congruency. These are the reasons you can use to prove congruency. So now that you remember this, very important, let's look at option 1. So what do we do? Construction. Join OA and OB. Why? So that we can have them form 2 right-angled triangles. Join OA and OB. They're joined. OA and AB are joined. So now we have 2 right-angled triangles. So now in these triangles, in triangle, now I want you to stay with me, focus. In triangle OPA and triangle OPB, notice the order of the lettering, very important. OP is the common side and PA is the side that is equal to PB. So OP is common in both of them, and then we've got PB equals to PA. Very important. And then these 2, you're going to see exactly how they are connected. So we pick one. We've got a right angle already. Right angle triangles, the best one to use is RHS. Right angle hypotenuse side. You can use the other ones as well, it's not a problem. However, because we only have one angle that is given to us, which is that right angle, the best one to use is the right angle hypotenuse side, or one that only requires one angle to prove that congruency. So let's go. Now in triangle OPA and triangle OPB, we want to prove congruency. So we go OP. OP is common, or let's start with the angle. Angle OPA, which is the right angle. Angle OPA is equal to angle OPB. They're both equal to 90 degrees, and that is given. We are given that. That's the reason. Must always have a reason, and it must be valid. So that's step number 1. That is the R part of our RHS. So we decided to use RHS as our proof. Now next, hypotenuse. There we go. OA. All right. Notice OA equals to what? OB. All right. OA equals to OB. OA equals to OB. What are they? Equal radii. This side is equal to that side. They are both radii from the same point. The radius of a circle is exactly the same size anywhere you draw it. So what is the reason? The reason here is simple: equal radii. So we've got the right angle sorted, the hypotenuse sorted. This is the hypotenuse. There. Next, the last one is the side. What is the side that we're going to use? We can use the common side, okay, because this one is not given to us. Yes. So the common side is what? OP. OP is equals to OP. Notice OP is equal to OP. OP is equal to OP, and the reason this is the case is that it's a common side. You can just write common if you're lazy. It works extremely well as well. So we've got the last bit. So we've got the R, we've got the H, now the S. Now we can make that conclusion that the two are congruent. Therefore, triangle OPA is congruent to triangle OPB, and the reason is right angle hypotenuse side. Yeah. Now that these two are congruent, you know that congruent triangles are equal in every respect. The corresponding sides and the corresponding angles are identical in size, they are identical in shape. Now that that is the case, now that we have proven that these two triangles are congruent, we can then conclude that AP or PA equals to PB. Therefore, side PA on the left hand side is equals to side PB on the right hand side. Now, if AP equals to PB, PA equals to, it doesn't matter how you want to put it. You can write AP, it does not matter. Right. AP or PA equals to PB. Therefore, that means the conclusion you can make, if AP is equals to PB, therefore it means that P by OP bisects the chord. Therefore, OP bisects the chord, bisects AB, the chord. And that is the end of the proof. You have proven it. That's it. Now let's go over this. Okay, step number one, we looked at the theorem, pulled it apart, explained the words, dissected them, and understood exactly what they meant. All right, next we looked at the goal. What is it according to the theorem we are required to prove? We are required to prove simply that AP equals to PB. Number three, we looked at the strategy. Now, the first option is the congruency, and this is how we applied it. All right, good. Now, let's look at option two, the other way you can prove this theorem. So that you choose one. You don't need to do both of them during a proof. One is more than enough. So using this one, all right, we use the option two is Pythagoras. So we use the theorem of Pythagoras to prove that AP is equals to PB. How do we do that? Now, we join OA and OB. Same story, join OA and OB. Now that they've been joined, right, now you can say, because we have a right angle triangle, right, okay. In triangle OPA, this is what we have. OA squared equals to OP squared plus AP squared. OA squared equals to PO squared equals to OP squared. All right, let's use OP. It's equals to OP squared. Sorry about that. It's equals to OP squared plus AP squared. And the reason is Pythagoras. Whenever you have a right angle triangle, you can do that. The square of the hypotenuse is equal to the sum of the the squares of the two other sides. Also, in triangle OPB, the square of the hypotenuse OB is equals to OP squared plus AP squared. OB squared equals to OP squared plus PB squared or BP squared. It's up to you how you. Same reason Pythagoras. All right, good. But notice one thing. OA equals to OB. But OA is equals to OB, and the reason is that they're equal radii. But OA equals to OB, reason equal radii. What are we trying to get to? Now that these two are equal, therefore it means that OA squared is equals to OB squared. If OA equals to OB, then the squares are also equal. Therefore, OA squared equals to OB squared. So what we do now is we just basically substitute this. OA squared is OP squared plus AP squared. So on the left hand side, we got OP squared plus AP squared. And then on the right hand side, OB squared is what? OB squared is OP squared plus BP squared. OP squared plus BP squared. But notice that OP squared, these are identical, so you can just basically, they cancel each other out. That leaves you with what? AP squared is equals to BP squared. Now, if AP squared is equals to BP squared, therefore the square roots of these are also equal. Therefore, AP is equals to BP, meaning that therefore OP bisects AB. And that's how you prove it. And that is how it is to prove. That's how you prove it. Right, now let's look at how this theorem is applied in examples. All right, before we do that, let's go back to the theorem. Just a quick one. I just wanted you to notice something, that the theorem, the reason we use for the theorem, whenever we use the theorem to prove another theorem or to work out whatever it is that they need you to work, is that perpendicular from center bisects chord. Perpendicular from center bisects chord. That's the reason we use. Screenshot it and know it. In the diagram, this is from the November 2018 Department of Education, grade 11 caps. In the diagram, O is the center of the circle. There, O is the center of the circle. Chord AC, there is AC, is perpendicular to OD. There is OD. This chord is, okay, at B, there. OB is equal to 2x. OB is equal to 2x units. And AC is equal to AC units. AC is equal to 8 units. Show that the length of BD is 2x in bracket square root of 5 minus 1 units. Now let's annotate this diagram. So we are told OB equals to 2x. The OB equals to 2x. Let's annotate that. We are also told that AC equals to 8 units. AC equals to 8 units. There is AC. This is 8x units. And AC is perpendicular, so we have a right angle triangle. Show that the length BD, this is BD, all right, is equals to 2x in bracket square root of 5 minus 1. All right, from the theorem, we know that AB is equals to half AC. AB is equals to half AC. Perpendicular from center bisects chord. That's the theorem we just used, and this is the reason. Bisects chord. That's why AB is half AC. So meaning that if AC is equals to 8x, therefore AB will be equals to 4x, which is equals to, therefore AB is equals to half times 8x, which is equals to 4x. This is a right angle triangle. We've got AB, we've got OB. Now what we need to find is BD. So BD, we know that BD is equal to OA equals to OC equal radii. So what we need to do is to find OA, and that will help us find the rest of BD. So now we know OA squared equals to AB squared plus OB squared. AB squared plus OB squared. Pythagoras, it's a right angle triangle, so we use Pythagoras. Now we substitute. Always start it with it like this and substitute, because you get marks for that. So let's substitute now. OA squared, that's what we're looking for. Let's substitute OB squared and AB squared. So that will be 4 squared. Therefore OA squared equals to, AB is 4x, so that will be 4x all squared plus, and OB is 2x. That will be 2x all squared. So that gives us what? Therefore OA squared is equal to 16x squared plus 4x squared, which gives us 20x squared. This is equals to 20x squared. Meaning that therefore OA will be equals to the square root of that, 20x squared. So leaving us with square root of 20x. Can leave it like this for now, but we can obviously go fix it. Okay, square root of 20, that gives us square root of 20, that gives us 2 root 5. 2 square root of 5, let's go. So that will be equals to, therefore OA equals to 2 root 5x. So we've got that the diameter, but OA equals to OD. But OA equals to OD, and the reason is equal radii. All right, now therefore BD will be equals to OD minus OB. BD equals to OD minus OB. We know that BD is equals to, OD equals to 2x. So therefore that is equals to 2x minus OB is equal to, oh no, OD is what? OD is equals to OA, sorry. OD is 2 root 5. 2 root 5x minus OB is 2x. 2 root, okay, correct. Now all we do is we simplify this. So take out a common factor. That will be x. And that will leave us with 2 root 5 minus 2. Take out a common factor of 2 over there. That will be 2x. And then it will leave you with root 5 minus 1. And that is the answer that they gave us here, which is correct. We've shown that, and that is how you do it. Easy peasy. Next, let's look at another example. O is the center of circle PSQ. There. Chord QP, there is the chord, such that OS is perpendicular to QP at T. There. OT equals to 7 centimeters. There is OT. QT is equals to 24 centimeters. There it is. And TS equals to X centimeters. TX is this one. Calculate the length of X. Well, it's very similar to what we had there. So we know that OS is equals to OP. So, but first we know that this side QT is equals to TP. And the reason is the perpendicular line from center bisects chord. So first of all, let's go QT equals to TP equals to 24 centimeters. Reason, perpendicular bisector, perpendicular bisects chord, perpendicular from center, bisects chord, perpendicular from center, bisects chord. So if this is 24 centimeters, that TP will also be 24 centimeters. So we know we've got this one, it's 24 centimeters. Now let's use the theorem of Pythagoras to find the hypotenuse, which is OP. OP squared equals to OT squared plus TP squared. OT squared plus TP squared. Let's substitute. OT is 7 centimeters. So that is 7 centimeters. And then TP is 24 centimeters. All squared. So that leaves us with, therefore, OP is equals to the square root of that. So it's the square root of 7 squared. Square root of 7 squared, sorry about that. 7 squared plus 24 squared. And that gives us 25. That is equals to 25. So 7 squared plus 24 squared. That is equals to 25 centimeters. Now that we've got OP equals to 25 centimeters, that is the radius, equal radius, 25 centimeters. All right, now we can find X because OS equals to OP, but OS equals to OP, and the reason is equal radii. Equal radii. And now we can find X. OS minus OT equals to TS. Okay. TS equals to X equals to OS minus OT. All right, therefore, okay, let's go this way. All right, so therefore, X equals to Therefore, x equals to OS minus OT. OS is equals to 25 centimeters, so that will be 25 centimeters minus OT is 7 centimeters, and that is equals to 25 minus 7, 25 minus 7, and that gives us, 25 minus 7, 25 minus 7, that is equals to 18 centimeters, and that's how you find that. So that is the answer to the question, and we've come to the end of this video. Thank you so much for watching. I'll see you in video 2 and video 3. Bye bye.